And liquid water once again flows in the rivers, the canals, the channels, and the oceans of Mars.
When NASA's Perseverance rover touched down on the surface of Mars in February 2021, it wasn't just another milestone in space exploration. It marked the beginning of a whole new era. Equipped with the most advanced suite of cameras and scientific instruments ever sent to another planet, Perseverance was designed to do more than explore. It was built to reveal Mars as we've never seen it before. And now, for the first time, we are witnessing Mars in stunning 4K resolution, crisp, clear, and breathtaking beyond belief. The rover's entry, descent, and landing were filmed by a suite of high-definition cameras strategically placed on different parts of the spacecraft. These cameras captured every second of the thrilling 7-minute descent, including the deployment of the supersonic parachute, the ignition of the descent engines, and the final moment when Perseverance was gently lowered onto the Martian surface by the Sky Crane system. For the first time in history, humans were able to watch, in ultra-high definition, the actual process of landing on another planet, something that had only ever been imagined before. But that was just the beginning. Once Perseverance began its mission on the Martian surface, it began sending back some of the most detailed and vivid images we've ever seen from another world. Its Mastcam-Z camera system, mounted on the rover's head, functions like a set of high-powered eyes. This sophisticated imaging system can zoom in on distant features, stitch together panoramic views, and even record full-color video in 4K resolution. When these images and videos are transmitted back to Earth, they offer an unparalleled glimpse into the Martian landscape. Imagine being able to see the rusty red terrain, ancient riverbeds, scattered rocks, and even dust devils swirling across the surface, all in jaw-dropping clarity. For planetary scientists, this footage isn't just beautiful, it's valuable data. Every frame can be analyzed to understand the composition of rocks, the presence of ancient water flows, and the weather patterns that continue to shape the Martian environment. The detail is so high that you can spot individual grains of sand, the textures on Martian rocks, and even the marks left by the rover's wheels as it travels across the surface. This resolution allows researchers to study geological formations in ways that were never possible before, helping them to identify promising locations for sample collection and further study. These samples, once collected, are planned to be returned to Earth by future missions, potentially answering the question of whether life ever existed on Mars. Perseverance's SuperCam, perched atop the rover, adds another layer to this visual experience. It's not just a camera, it's a powerful combination of laser, microphone, and spectrometer. The laser zaps rocks to analyze their chemical composition, while the microphone picks up the sound of the laser strikes and ambient noises like Martian winds. When combined with 4K video, this data creates an immersive sensory experience, sight and sound from a world millions of kilometers away. One of the most stunning moments captured in 4K came when Perseverance filmed the Ingenuity helicopter taking off and hovering over the Martian surface. This small drone, the first aircraft to fly on another planet, demonstrated that powered flight was possible in the thin Martian atmosphere. Watching Ingenuity lift off, rise into the air, and hover with perfect stability, all in ultra-high definition, felt like something straight out of science fiction. Yet, it was real. The Mars helicopter made multiple successful flights, each one recorded by Perseverance's high-res cameras. The footage showed the helicopter casting its shadow on the ground, creating a surreal image of human-made flight in an alien world. It was a triumph not only of engineering, but also of visual storytelling. These videos didn't just document history, they made people feel like they were there, standing on Mars, watching it happen with their own eyes. More than just pretty pictures, the 4K footage also helps mission planners and scientists assess terrain hazards, plan the rover's path, and determine where to direct future scientific efforts. By zooming in on interesting features like layered rock outcrops or unusual formations, the team on Earth can decide where the rover should drill, sample, or analyze further. It's like giving the rover a superhuman set of eyes that can look ahead, scrutinize, and choose the best scientific targets. And these breathtaking visuals aren't just for scientists. NASA has made much of this footage available to the public, allowing people all around the world to witness Mars as if they were standing there themselves. The vividness and clarity of these images are helping to fuel a renewed interest in space exploration, inspiring a new generation of scientists, engineers, and dreamers. For school children, the elderly, and everyone in between, seeing Mars in 4K bridges the distance between planets. It turns curiosity into connection. What makes this footage even more astonishing is the level of planning and innovation that went into making it possible. Mars is, on average, about 225 million kilometers away from Earth, and transmitting high-resolution video across that vast distance is no small feat. The data rates are extremely limited, and each file sent back to Earth must be carefully compressed, prioritized, and transmitted through NASA's Deep Space Network, a global system of powerful antennas. This network is responsible for maintaining contact with all of NASA's interplanetary spacecraft, ensuring that even high-bandwidth content like 4K video can make its way back to Earth, albeit slowly and methodically. Once the footage arrives, it undergoes a process of decoding and rendering to reconstruct the full-resolution video. NASA's imaging specialists then work to enhance the visuals, correcting for lighting conditions, stitching together panoramic views, and sometimes even using AI to reduce noise and sharpen details. The result is not just video content, it's a cinematic experience from another planet. One of the most iconic 4K sequences released so far shows Perseverance making its way across Jezero Crater, the ancient river delta chosen as the rover's landing site. This crater is believed to have once held a lake billions of years ago, making it a prime location in the search for signs of past life. As Perseverance navigates this rugged terrain, its cameras capture the layered rock formations that could tell the story of Mars's ancient climate and geology. The footage shows dusty hills in the distance, rippled sand dunes, and fractured rock slabs that may have formed in the presence of water. At one point, the camera captures the Martian horizon during sunset. The sun appears smaller than it does on Earth and casts a bluish hue, a stark contrast to the golden-orange sunsets we're used to. These images reveal just how alien yet familiar Mars can be. You see a barren landscape, yes, but also the telltale signs of erosion, the presence of weather patterns, and even seasonal changes like frost on the surface during colder months. Another unforgettable visual is the recording of dust devils in motion. These mini tornadoes whip across the Martian surface, kicking up columns of dust as they go. In 4K, you can track the movement of individual dust particles and see how they interact with the surface. It's a dynamic, ever-changing world, not the still dead planet it was once thought to be. Then there are the close-up shots. When Perseverance uses its robotic arm to investigate an intriguing rock or to collect a core sample, the cameras zoom in with astonishing clarity. You can see the drill bit in action, the texture of the rock, and even the moment the sample tube is sealed for future return to Earth. It's not just science, it's history in the making, captured in crystal-clear detail. NASA's choice to equip Perseverance with such advanced imaging technology wasn't just about improving data quality. It was also a way to enhance engagement. Public fascination with space has surged in recent years, and providing vivid, high-definition visuals from Mars helps turn that curiosity into deeper interest. When people see these videos, they don't just admire them, they ask questions. What am I looking at? How was this filmed? What does this mean for humanity's future? These are exactly the kinds of questions that NASA hopes people will ask. Because the mission isn't just about looking at Mars, it's about understanding it, preparing for human exploration, and ultimately answering one of the biggest questions ever posed. Are we alone? One key goal of the Perseverance mission is astrobiology, the study of life in the universe. By examining ancient sedimentary layers, researchers hope to uncover biosignatures, which are chemical or structural traces left behind by microbial life. The ultra-clear visuals help scientists identify the most promising rock samples and determine which areas might hold preserved organic compounds. These compounds, if found, could be evidence of ancient life that once thrived in Mars' now dry environment. Beyond that, Perseverance is laying the groundwork for future missions. The samples it collects will eventually be picked up by a follow-up mission and returned to Earth, something that's never been done before. This Mars sample return campaign is one of the most ambitious endeavors in the history of space exploration, and the 4K video being captured today will help ensure its success by giving scientists and engineers a better understanding of the Martian terrain, guiding them as they plan the next phase of exploration. Another fascinating aspect of Perseverance's imaging system is how it works with other instruments to form a complete picture. For example, after the rover identifies a rock that looks geologically interesting, it can zoom in with Mastcam Z, analyze it with SuperCam's laser and spectrometer, and then use its robotic arm to get even closer. All of this is documented in high-definition visuals, creating a rich, layered data set that combines imaging, audio, and chemical analysis into one seamless narrative. This integration of technologies marks a new era in how we explore other planets. It's not just about sending robots to collect data. It's about creating immersive experiences that let us interpret that data in meaningful ways. It allows scientists to collaborate across disciplines: geologists, chemists, biologists, engineers, and even filmmakers working together to tell the story of Mars. What's even more impressive is that these videos are being captured in a harsh environment where temperatures can plunge below -80 degrees Celsius. Dust storms can rage for days, and solar radiation is intense. Despite these conditions, the cameras continue to operate flawlessly, protected by carefully engineered housings and systems that keep them functional in extreme conditions. Even the sound captured by the rover adds depth to the 4K visuals. The microphones have picked up wind gusts, the crunch of wheels moving over gravel, and the pulsing zap of the laser as it studies rocks. When combined with the visuals, it gives viewers a fuller sense of presence, something no previous mission could offer. All of this comes together to create an unprecedented view of Mars, not as a distant, lifeless rock, but as a world with a complex history and enormous potential. The 4K footage captured by Perseverance allows us to see that history etched in the cliffs, dunes, and riverbeds of Jezero Crater. It makes Mars feel tangible, real, and just within reach. For the first time, we're not just imagining what it's like on Mars, we're seeing it, almost feeling it. The crisp visuals, the sound of Martian winds, the sight of dust devils dancing across the plains, all of it connects us more deeply to this neighboring planet than ever before. It's not science fiction anymore. It's real, and it's happening now. As more 4K footage continues to stream in, we're witnessing not just Mars, but the future. A future where robots pave the way for astronauts. A future where the red planet is no longer a mystery, but a destination. And it all starts with the images, clear, vivid, and utterly breathtaking.